Hello and welcome. In this video we want to do some questions about limits at infinity. The first question is, what is the limit of 2x to the power of 3 minus 5x to the power of 2 when x approaches infinity? For finding this limit, you can factor the highest degree that appears in this expression, which is x to the 3. And by factoring x to the 3, we have 2 minus 5 over x. Attention, this term has only x to the 2, and because we factored x to the 3 from that term, we get fraction 5 over x. And x approaches infinity. And the reason that we factored the highest degree of the bracket is that we know this general rule that limit of any number over x to any positive power, let's say x to the power of 1, x to the power of 2, any positive power of x, limit of this form, limit of any number, 5 is a number, over x with any positive power, limit in this form is equal to 0. And because we know this general rule, we factor the highest degree from the expression. Then we have this. Now by looking at the bracket, limit of the 5 over x when x approaches infinity based on this rule is 0. So the bracket is 2 minus 0 when x approaches infinity. So the limit of the bracket is 2. But here we have x to the 3 which goes to infinity. So the limit equals infinity. Because this is infinity, times by 2 is also infinity. So the limit of this expression when x goes to infinity is infinity. Look at the next example. We want to find limit of 2 radical x minus x when x approaches infinity. It's not a bad idea to pause the video right now. Try this question by yourself and then continue watching the video. Similar to the previous question, for finding this limit, simply you can factor the highest degree in the bracket between this term and this term. In this term, x to the 1/2 we have. Here we have x to the 1. So the highest degree is x to the 1. So we can simply factor x to the 1 or x from the bracket. By factoring x, or actually x to the 1, and attention, this term is 2x to the 1/2. What we get? We get inside the bracket 2 radical x over x minus 1. We factored x, so because we factored x, we have to divide this term by x. So we have 2 radical x over x. But if we simplify, this term is 2x to the 1/2 over x to the 1. If we subtract this power from 1, we can write this as 2 over x to the 1/2. Here the power is 1, here the power is 1/2, so this cancels with this, and from x to the 1 only x to the 1/2 remains. So by factoring x, we get 2 radical x over x minus 1. And when we simplify this expression here, that expression can be written actually as 2 over radical x. 2 over radical x. And now, because x approaches infinity, limit of this part is 0. Limit, remember, limit of any number over x to any positive power. Radical x in the denominator is x to the 1/2. So limit of any number over x to any positive power is 0. 0 minus 1 is negative 1. So this expression inside the bracket is negative 1 when x approaches infinity. When we multiply negative 1 by x, it's negative x. And because x goes to infinity, so negative x approaches negative infinity. And so the limit equals negative infinity. So when we don't have fractions and we want to find limit of functions that are not in the fraction form, they are not rational expressions, you have to factor the highest degree between the terms that you have, and then you can make in this way fractions, and by using this rule here, limit of any number over x to the p equals 0, you can find the limits.